All right, so you should be looking at this. Let's refresh from the 3-act task from yesterday. How many eyes? So day 1 was how many? 4. Oh, let's make this interesting. We're going to write on a, no, I can't make it. There we go. Day 1 had 4 eyes, correct? Not like me right now, 4 eyes. No, bad joke. That's all right. I wear glasses, I can make fun of myself. Day 2, how many eyes? 8. Day 3, how many eyes? 16. And the question was ... Day what? Do you remember? 25. The question was, give me the number of eyes for day 25. And some people came up with ways to do it, because I think somebody got it right. Maybe. Did anyone get it right? Somebody got close? One more? What'd you get to? Did you remember? You wrote it on the back, by the way.
33 million.
33 million? Can you tell me what you did?
Well, I did 2 to the 25th power because there was 2 sets of eyes on day 1, but I should have done 4 for 4 eyes. So, to the 25th power.
Okay. Can you tell me what 4 to the 25th power is on your calculator right now, if you don't mind? Do you know how to type it in there? Is it a gigantic number? Does it say E? If it says E, that means it's in scientific notation, which means it's either incredibly small or incredibly large. Since you are raising 4 to a power of 25, you would think it's getting incredibly large. So I like the way that you're thinking it's 4 to some power. What was the pattern to go from day 1 to day 2, y'all? How did we get from 4 to 8? Okay, you're counting the pairs of eyes, aren't you? Okay, tell me another way to do it. That does work. I want you to think of multiplication. How do I get from 4 to 8? Doubling it? Multiply it by, if I multiply it by 4, I would get 16. So I'm multiplying it by 2. And what about here? 2. Right? Okay. You were playing with a geometric sequence. How do I know? Because what was the difference between them? It was times a number every time, okay? That's a geometric sequence. This is right in line with what we just did with exponential equations. So now what we're going to do is we're going to talk about them as sequences of numbers. By the way, the word sequence is just a fancy word for a list of numbers that have a common pattern between them, okay? You can have 2 types of sequences. Arithmetic, which a lot of people pronounce it arithmetic, and that's actually not incorrect at all. It's just you're going to hear me call it arithmetic because it kind of rolls off the tongue better. Or there's geometric. Looking at your EOC formula sheet, can you please put your pencil on arithmetic sequences? Kanan, if you'll close your Chromebook so you're not tempted to play that game. Thank you. Put your pencil on arithmetic. Did you land here? Yes? No? Okay, put your pencil on geometric. Geometric. Did you land here? What words do you notice are in both? This is a mathematical teaching practice, being able to look at two things and compare what's the same, what's different. What words are in both of those sections of formulas? Sequence. So both of those refer to when you have a list of numbers that have a pattern between them. What else is in both of them? What words? Formula, which means that this is something that you should be able to plug in and get an answer to every time. What else? Look at the two sections of words and tell me what else is in both. What word has been copied and pasted in both of those pink highlighted sections? We've already said sequence and formula. What else? Thank you. Say it a little louder with confidence. Recursive is in both. What else? Explicit is in both. There are two types of formulas with a sequence. Recursive, explicit. In a nutshell, y'all, recursive means next term. You have to return to the previous term to find the next term. Explicit means specific term. Could be really far out at the end of the list. Could be the 100th term, 200th term. You really don't want to sleep through this because this is very easy on the test Friday. So recursive means return to the previous term to give me the next one. Explicit means specific, like the 500th term in the sequence. I don't want to sit here and find the 499 terms before it just to get the next one, right? I want to just find the 500th term. You see the difference between the two? Okay. Y'all are night and day from second block. Like second block, I can't get them to focus or be quiet. And y'all are, is it food, like food comas? Everybody's belly's full from lunch and you're like, yeah, no, okay. Work with me here. Lean in, okay? This is really, really not that bad. Let's dive into it. Let's take a couple notes. You learned arithmetic in August. Yes, I know you've slept since then. Yes, we are going to practice it to make sure that you're refreshed on it, okay? Because it is on the EOC. But geometric is new. Now, I'm going to show you this geometric today, and it's very similar to the arithmetic, so it should start coming back to you. The main difference, here you go. Here's your game plan. The main difference is arithmetic involves adding and subtracting. Geometric involves multiplying. Okay? So if the sequence is just adding up the same number every time, it's arithmetic. If it's subtracting by the same number every time, it's arithmetic. But if you're having to multiply by a number every time, it's geometric. Okay? I haven't thought of a really crazy way to help you remember that, other than the fact that arithmetic means add and subtract. So geometric is the other one, multiply. That's the only thing I can think of. All right, so let's dive into the notes. A geometric sequence is where each new term after the first is obtained by multiplying by a common ratio, R. Common ratio, R. that common ratio, if you have highlighters here, it would really help to color code stuff. That common ratio is going to appear in both possible formulas, because that's the difference from the numbers, between the numbers. Now, you might be thinking, well, what's the difference in terms of explicit and recursive? I want you to take these notes. Like I just said, recursive requires you to return, make a note, you're going to return to previous to find the next. You return to the previous term to find the next. That's recursive. And then you look at this and you might be thinking, this is a hot mess. I have no clue what all this is. I'm going to get to it in a minute. Right now, I just need you to know, basically, recursive means return to the previous term to tell me the next term in the sequence. Okay? Explicit means specific. Like if I wanted the 500th term in the sequence, I don't want to sit here and find all the ones before it. I want to jump straight to specifically term 500. Okay? Stay awake. All right, now here's what I need you to know. You know how when we learned this equation, you learned it in 8th grade, but we worked with it. What is this? Slope, intercept form. And you know how we said you only plug numbers in for which variables? M and B. Think of like mind your business, right? We only plug numbers in for M and B. So for example, if I said, hey, go graph this, y equals 3x plus 1. That's an equation of a line. The slope is M, the B, y-intercept is 1. Do you notice how we don't plug anything for x and y? We write x and y as our formula. And that's because that's how we can go graph it. And now I can pick any number x I want, plug it in, and I get my y. The same thing goes for sequences. I'm going to put, I don't know what color, I'll do gray. I'm going to put gray. A sub n and a sub n minus 1 are variables. When you're writing the actual formula means there should be variables in it so I can plug stuff in, right? When you're writing the actual formula, you don't plug anything in there. If it says, hey, give me the formula, that means I better see an a sub n, I better see an a sub n minus 1. Same thing over here, a sub n, and then right here on n minus 1, that's part of the formula, okay? Now, what's different that I've not highlighted yet in one of the formulas? Which one have I not highlighted? A sub 1. A sub 1 means first term. So I want you to look at this example right here. Focus your attention right there. 3, 9, 27, 81, right? Look at those numbers. 3, 9, 27, 81. Without telling me out loud, tell me, how do I go from 3 to 9? 9 to 27, 27 to 81. Don't tell me out loud. Don't tell me out loud. Look at them. Think of, how do I get from one to the other? Now, I'm going to ask you 2 questions. I want you to put your heads down, and I want you to hold your hand up. Here's the first question you're going to answer. Is it arithmetic or geometric? Is it adding by a number or multiplying by a number? So I want you to hold your finger up. 1, if it's adding. 2, if it's multiplying. Adding or multiplying from one number to the next. If I tap you on the shoulder, it's because you're not participating or it's because your answer's wrong. 1 adding, 2 multiplying. One adding, 2 multiplying. 100%. Heads up. Second question. With a show of hands, I want you to hold up the number of fingers that it's multiplying by. Heads down. Hold up a number of fingers that it's multiplying by. How's it going from one to the other? Hold your fingers up for me. Let me see. If I tap you on the shoulder, you're wrong, or you're not quite participating, and I need you to. If I tap you on the shoulder, I need you to glance at your paper while your head's down and check again. What is it multiplying by to get from one to the other? Almost there. 100%. Very good. Love it. Heads up. Okay, so you all agreed it's multiplying from one to the other. You all agreed it's multiplying by the number 3. So I want you to look right here. It says, get closer to the sensor. It says, write the recursive formula. So first of all, let's come over here and make a note. Our ratio, meaning our multiplier, is 3, right? It's getting bigger, so this is a big number. Let's write the recursive formula. The fact that it says formula right here means you are going to show me an and an minus 1. So look up here. Formula is a sub n equals. Now, you do need to plug in for r. What was the multiplier? 3. And then the next part is a sub n minus 1. That's it. This may feel like hieroglyphics, right? Y'all still study about that, right?
Nope.
Yes? No? You know, they took Pluto out of this system of planets. We learned Pluto was a planet, now we got gyps. So, do y'all still learn about hieroglyphics? Egypt? You don't? You don't? At all?
Maybe not yet.
It looks like y'all's emojis to each other, basically. Just not in color. So this probably looks like a bunch of emojis. There you go, I'll talk your language. And you might be thinking, how in the world did you, I don't understand that, but I totally understand how to get from 3 to 9 to 27 to 81. Here's my question to you. Using your calculator, and I'm going to walk around, I want to see everyone's calculator. I want you to tell me what is the next term in the sequence on your calculator screen. Tell me the next term in the sequence. If I put your calculator down, it's because it's correct. Can't see it. Good, good, good. Come on, I need to see it. Let's go. Why do you not have a calculator? Where's your phone? You just forgot to get it. Are you locked? Let me see on your calculator, what's the next term in the sequence? Yes. Let's go. Come on, show me. Let me see it. Jackson, let me see it. Yes. Yes. Did you show? Okay. Yes. Let me see. What is it? Thank you. Okay. You know how easy you just found that the next term is 243? What'd you do? What'd you multiply by 3? Where's 81 in the sequence? It's the last term that we know, right? Okay, so here's my point to you. Do you see how you naturally, without any formula, knew just to go to the last number and multiply by 3, right? You are naturally doing the recursive formula because you're going to the last thing you know, you've already found a pattern, and you're just multiplying by the pattern. So that's the recursive formula. Let me show you how to read it. The next term, a sub n means like the one you want, is, look what I'm pointing to. what I'm pointing to in the video, the next term is 3 times the last term. That's all this is. Don't let the a sub n and the a sub n minus 1 make you feel like it's like talking above your head and you're like, I don't understand that, but I know it's times 3. That is when you're doing the times 3. Like you're actually doing it, you just don't realize it. So here's what's funny. Well, we'll wait. Okay, so it says find the next 3 terms. Well, you just found one of them. 243. There's not a lot of room here, and I'm really sorry. Please find, you know what, let's write them over here, because that's ridiculous. Let's write it over here. So this would be 243, and then I need you to find the next 2 terms. Then I want you to turn to a neighbor, and I want you to compare. And do you have the same answers? Now, somebody tell me, because I can't do 243 times 3 in my head without growing a gray hair. What is it? Huh? Okay. And then the next one? A little louder. 2,187. Okay, I'm not going to put a comma there because I don't want it to look like I said 2 was the next number. You know what I mean? Okay. Now let's look at explicit. We're going to look at the exact same sequence of numbers, but now we're doing explicit. Remember, explicit means specific. If you've ever had an adult tell you, I explicitly told you, what they mean is like I very clearly and specifically said the following. So that's one of the things, like when I leave, like if I have my second block, since I don't have a co-teacher in there, I always tell them I have left explicit directions. You should know what to do. There's no questions about, like, you know, how to behave. Explicit means specific. The words sound almost similar. It's when you need a term kind of farther out and you don't want to sit here and find all the ones before it. Ain't nobody got time for that. So how do we write the formula? Well, first, you go to your formula sheet, because no one's asking you to memorize these, and you look at the explicit formula based off of the pattern you found. Because it was times a number, that tells me go to geometric. Because it says explicit, that tells me to go to explicit, right? Here we go. The formula is a sub n equals, you do have to plug numbers in for a sub 1 and for the r. A sub 1, by the way, means I don't understand, because like if I touch anything on here, it's always here. But I don't know. There's no telling. A sub 1 means the first term in the sequence. What was the first term in the sequence, y'all? 3. Times, what was our multiplier? 3. And then it says, this is in the exponents place, by the way. And notice I gave it a gray color, and that's because when you're writing the actual formula, you have to leave that as n minus 1, so that now it's what's called generalized. Meaning I can use this no matter if I want the 15th, the 20th, the 400th, the 1000th term. Doesn't matter. Heck, I could even plug in 2 for the second term, and I would get 9. All right, so now what I want you to do is it says, tell me the 15th term. Let's come right here and write it so there's more room. So the 15th term, we would go to our calculator, And we would enter 3 times 3 to the what? 15 by itself?
No.
Remember, it's n minus 1.
Oh.
So it's not the 15th power, it's the 15, n minus 1, right?
Mm-hmm.
And I want the 15th term. 15 means that's your n.
15 minus 1.
Yes. I would not type 15 minus 1 in the calculator. I would go ahead in your head and say 14. And the reason for that is because the minus 1, if it bumps down out of the exponent's place, it's going to give you the wrong answer. So I would just go ahead and say this is 3 times 3 to the 14th power. Does everyone understand where the 14 came from? Now can you read me the number? And I know it's a massive number. What is it?
4, 7, 8, 2, 9, 6.
2, 9, 6, 9. 4,782,969. That's not what you got? That is not what she got. Let's double check show Coach what you got in your calculator so you can see it. Did we get 1, 4, 3, 4, 8, 907? So 14,348,907. Yes? Jackson, you with me? Ho, with me? All right, now watch this. Y'all are going to get so mad at this. Watch. Remember this?
Mm-hmm.
Please use the explicit formula right now to find the 25th term. Use the explicit formula right now to tell me how many eyes would there be on day 25. So what 2 things do you need for explicit? I'll write the formula right here. Remember, you need base of 1, your multiplier, and then you need to know n, like which one you're trying to find. All right. So, what is my first term? What? 4. What's my multiplier? 2. And I want what term?
25.
The 25th term? I just realized I should have put 25 right here. Minus 1. So in your calculator, you should have typed 4 times 2 to the 24th power. And tell me what you get. You can round to the nearest million. You don't have to read the whole thing. What'd you get? 67 million. So that was yesterday's 3-act task. And if you had already known about geometric sequences, you could have taken this shortcut to get there. Instead of having to multiply by 2 25 times, right? You with me? All right, I've taught you everything you need to know. Now let's dive into the practice. I would like you to look at 1 through 3. State whether the following sequences are arithmetic or geometric, and then tell me the ratio or the difference. Here's where you should be problem solvers. It says, tell me the common difference or common ratio. Look at your formula sheet. Which one has a common difference? Which one has a common difference? Difference. Difference. What does difference start with?
D.
Huh? What letter? What letter, y'all? D. Wow. Okay. Please don't be that kid that on a problem on the EOC, if it says like find X, don't circle the X in the picture and say, there it is. You know, difference starts with help me out. This is painful. I'd rather go get my teeth cleaned than listen to y'all be so quiet. Oh no, I don't like the process. I can't stand the noise. I love how it feels after. Can't stand like the noise.
I don't like the.
Yep.
I pick on teeth.
Oh, they like feel so like or I
It's
think
like
like
nails on chalk.
when they like blow in your mouth, like your mouth gets open. See that one?
And now we're awake. All right. See, I woke you up.
Woke up.
So, please tell me which formulas would possibly have a common difference. What? Arithmetic. What is the common sense reason of why that is? Yes. I was really just going for the fact it's the only one with a D in the formula. Right? So yes, and difference does mean subtracting, or it can mean if you're adding. Ratio means what? Ratio? It's under explicit because what letter does ratio start with?
R.
And what's in the explicit formulas? R. Or not explicit, the geometric formulas. Okay, so right here, you're telling me if it's arithmetic or geometric. Arithmetic means it's adding or subtracting by the same number. Geometric means it's multiplying by the same number. Common difference is under arithmetic. Ratio is under geometric. So please go to number 2 right now and determine if it's adding by the same thing, subtracting by the same thing, or multiplying by the same thing. And then I want you to state what that is. Right here. Multiply. Which one should you write? Yeah. That one. on the ratio? What was the multiplier? Good. Oh, you don't have to, I'm sorry. You can erase that. You're not writing the formula, you're just telling me which one it is. Okay? You're just telling me which one it is, arithmetic or geometric. Good. Double check that. You're off. Just a little. Double check it. Alright, should be doing this. Do that one right there for me.
Chicken stuff.
What's that say? Okay. Don't get frustrated. Erase that. And here's your two choices. Okay. You're going to look at it and decide: is it adding or subtracting by a number, or is it multiplying by a number? And that's how you determine which one's which. Okay. And then it's either this word or this word because. All right, turn to a neighbor and compare number 1. Don't forget to tell me what it's multiplying or adding by. Compare number 1. This is where back up to this one. How do you go? You need a Band-Aid. Ow! No, you need a Band-Aid though, so you don't hit it. Compare your answers for number 1 and 2 with a friend. Compare your answers. 1 and 2. Any questions on 1 and 2? Yes? No? What'd you get for 1?
Yeah.
Hold on. All right. What did you say? And why is it geometric? Because it's multiplying by 2 to grow, right? If you think about it like times 2, times 2, times 2, times 2. So it's R, because it's geometric, times 2. Right? Next, not so pretty numbers. Probably had to use your calculator here. What you need to do is you need to ask yourself, this minus that number. So 3.1 minus 2.7. Everybody write now. Calculator. 3.1 minus 2.7. What do you get?
0.4.
Leave it. Repeat. Go to the next one. 3.5 minus 3.1. Recheck that. 3.5 minus 3.1. What do you get? Leave it. Repeat. 3.9 minus 3.5. 0.4. The fact that you got the same thing tells you that now you have your answer. You just have to remind yourself, is it arithmetic or geometric? What was I, adding or subtracting or multiplying? You have to look at it. What is it doing? It's growing, right? It's growing, so it's adding 0.4. Adding 0.4. Adding 0.4. Now you might be like, well, you were just subtracting. That's because we were trying to find the difference. We were trying to figure out, how did I get 3.1 from 2.7? I had to add 0.4. So it's arithmetic. And that means it's a common difference of 0.4. Stay with me, Bo. All right, let's look at the next one. Probably nothing comes to mind right off the top of your head. What do you notice is different here that has not happened yet? There is a fraction. Yep. So we're definitely not just adding and subtracting a pretty number, right? Because at some point we get a fraction. What else is different? What? Do you notice how there's some negatives in here? Now, are they all negative? No. How would you describe to me the positive and negatives in here? What would you say they're doing? They're changing each time. Great. Fancy SAT word for that, oscillating. Oscillating. It's a fun word to say. It's oscillating between positive, negative, positive, negative. The fact that it's oscillating between positive, negative is your clue that it's multiplying by a what? What type of number? Hold that thought. What? Negative. Because what's a positive times a negative? A negative. What's a negative times a negative? Positive. What's a positive times a negative? A negative. Do you see now how that is generating the opposite signs? So you need to think to yourself, like plus, minus, in terms of signs, means that it's multiplying by some negative number. Man, that looks like hieroglyphics right there. What I was trying to say is if it's going back and forth from sign changes, that's your clue. You're multiplying by a negative number. Now we've got to figure out what we're multiplying by. Ask yourself this. Ignore the negatives. What's the sequence doing? Is it getting bigger or smaller? It's getting smaller. So what type of number do I need to multiply by in order to make my list shrink? It's already going to be negative. Now that just changes the sign though, right? What actually makes the number shrink? Think back to exponential. Think back to when the base was involved. Bo, sit up. Kanan, wake up. What is it? It's 180. I don't have a lot of room over there. It's 180, negative 60, 20, right? And then what? Negative 6 2/3. Okay. So think back to exponential. Do you remember the exponential formula? Maybe? I think it looks like this. What does it say? B. Remember that? Which one was our multiplier? What? I heard it. B. And what did we say? If it was growth, B was what? If it was growth, B was... Huh? Okay, y'all. When we learn something, you got to try to remember it. B is what number compared to, like if it's growth versus decay. Think of the difference between the two. You're on the right track. Not quite positive. That doesn't really matter. But you're on the right track. If it's growing, the base multiplier should be what type of number? Yep, keep going. We just did exponential. Tie it back to what we did with exponential. Exponential growth versus decay, right? So the sequence is getting smaller, which means it's what, Kanan? Decay. Which is what's going to happen to our grades if we don't pay attention, right? They're going to decay. So the sequence is getting smaller, which means it's decay, which means the multiplier has to be, the multiplier needs to be, put it all together, y'all. Help me out. Less than 1. Now, figure it out. What is it? What do I multiply 180 by to get negative 60? You try to find it right now. What do I multiply 180 by to get negative 60? Now, we already said the fact that it's oscillating, you're multiplying by what type of number? Negative. Now, sit there and play with it for a second. That's dividing. Get it. And reverse these numbers and multiply.
So if you're trying to figure out what you do to it, you gotta work backwards.
Yeah. Almost. So like what Coach just said, if I'm trying to figure out how do I go from here to here, right? I know I'm multiplying by something, but I don't know what it is, right? Then come up here and say to yourself, well, I'll just work backwards. What's negative 60 divided by 180? Now, you're going to get a decimal. We need it in a fraction. You do need to, this is where Desmos might be a little bit easier because Desmos immediately pops up that box over box fraction button. On your graphing calculator, it's called Math Frac. Push the Math button, and the very first option says Convert to Fraction. Frac. Hit Enter. And you'll get negative 1/3. Very good. So, right here, this is geometric. This was a tough one. They're not all like this. But let's just remind you of a couple of things. Number one, we knew it was geometric because it's clearly not adding or subtracting the same number. Number two, we knew it was multiplying by a negative because it's oscillating between positive and negative. Number three, we knew it was a number less than 1 because the sequence is going down, right? So there's a lot to take in here. This is nowhere near as simple as number 1 over here. So let's pay attention. So we know it's negative, we know we're multiplying, we know it's shrinking. So it's a number less than 1. Now how do you find it? You come over here and you say, well, just go to the next one and divide by the last one. And then you'll hit Math Frac, okay? All right, please move to numbers 4, 5, and 6. You can do this. It says, tell me the common ratio. Now, these are all geometric, by the way. We're no longer practicing with arithmetic until you do your delta math. This is all geometric. It says, tell me the common ratio, then give me the formulas, then tell me a certain term. So right here, you're finding R equals, then you're getting the recursive and explicit. That means you're getting the next term formula, next, and then you're getting the specific formula. Please do that right. Get for the common ratio here. Those of you that did it, 5. Okay, recursive formula. That means all you have to plug in is R. You're just plugging in R. So, A sub n equals 5 times A sub n minus 1. What about your explicit formula? Explicit requires you to plug in A sub 1, which means first term. This is A sub 1 right here. For context, this is A sub 2, A sub 3, A sub 4, and so on. So for our explicit, what's A sub 1? Negative 4 times, what's our multiplier? To the n minus 1 power. Then it says find the sixth term. A sub 6 is, you would plug it into which one? Which one? Explicit or recursive? explicit, because that's specific, right? All right, and what do you get? Negative 12, is it 12,500? Negative 12,500. All right, what'd you get for the common ratio here? 0.75. Hit math frac and then tell me what you get. You get 3/4. So either one works. I will say that if it's a nice decimal that cuts off, go with the decimal, because then you don't have to worry about typing the fraction in wrong on the calculator. Desmos does type fractions in a lot easier, though. You'll have Desmos on the EOC. But recognizing if it's growth or decay also helps when it's in decimal form. Recursive, A sub n, all I need is R. You can put 3/4 or you could put 0.75. It's up to you. Times A sub n minus 1. Explicit. What's the formula for explicit? First term, which is what? Times what, Jax? Very good. To the what power? N minus 1. Thank you, Chloe. Find the ninth term. Malachi, which one would I use? Which formula? Recursive or explicit? And technically you could use either one, but explicit will get you there faster. So somebody read it to me. I'm pretty sure it's oh yeah, I remember now. So type it in your calculator and I think you get a decimal that is ugly. Yes? Then you're going to hit math frac because I don't think the sequence that they want you to do decimal. Math frac. What is it?
6,561 over 512.
Over
512.
Yeah, it's ugly. All right, look at this next one. The recursive formula of a geometric sequence is described below. Tell me the explicit, which means I need A sub 1. What's A sub 1? 2. Then I need the ratio, the multiplier. What is it? What is it? Okay, so since it's negative, it might be smart to put it in parentheses so it doesn't look like I'm writing 2 minus 3, right? To the n minus 1 power, right? All right, this should look familiar. A car depreciates by 20% each year it's purchased. Each year after you purchase it. As soon as you drive a brand new car off the lot, by the way, the value goes down immediately. That's why, like, a good rule of thumb, if you really don't want to lose money, is to buy like a gently used car. You know what I mean? One that's got low mileage on it, because now you're not paying that extra 20% where it was brand new. You know what I mean? Just a little tip. The table shows the value of the car. You bought it for how much? $12,000. It's going down 20% each year. We already learned that this is what type of relationship? Linear or exponential? Exponential. And another clue is the fact that it's percentage. Okay. Write an equation to represent this sequence. Just look at these numbers. 12,000, 9,600, 7,680, I think. Write an equation to represent the sequence. What's it shrinking by? So just like, where were we? Right here, where you had to find the fraction that it's multiplying by. I need you to do that here. Find what it's shrinking by. So you're looking for like 12,000 times what would give me 9,600. So we're going to go in reverse and say, well, 9,600 divided by 12,000. And then math bracket. 0.8. And because we're talking about money, it's okay if we want to leave it as a decimal. So write an equation to represent. So we found R to be 0.8. So A sub n equals, what's the first term?
12,000.
And it's multiplying by what? 0.8. Is it 0.8 or 0.08? 0.8. That's right, because look, it's depreciating by 20%. So 100 minus 20 leaves you with 80%. To the n minus 1 power. So how much is the car worth after 8 years? Find A sub 8. It should be like 2,000.
Yeah, I got 2,000.
Yeah, keep going.
516.
2,000.
516.58.
0.58.
Yes.
So it's money, so 0.58 cents. You have a Delta Math assignment that got posted during Flex where you're going to practice the combination of two, geometric and arithmetic. Most of them are geometric. You will need your formula sheet for arithmetic. If you had me in the fall, arithmetic is in your notebook. If you didn't have me in the fall, Miss Walker taught arithmetic. So you should have those notes as well.